I am Mampina Richmond, and we are starting a new lesson today, and it's on Pythagoras theorem. And all that we need to know about Pythagoras theorem is actually dealing with the right-angled triangle. That's all that we need to know. The Pythagoras theorem can only be applied to a right-angled triangle. So Pythagoras theorem states that for any right-angled triangle, square on the hypotenuse should equal to the sum of the squares on the other sides. Let's draw this. Let's take this one as a right angle triangle. Triangle of 90 degrees here. And let's say this is A, B, and then C on top. So the hypotenuse is the longest part, the longest side of the right angle triangle. So this is what we call the hypotenuse. Hypotenuse. Or we can say the hypotenuse is the line which is opposite to the 90 degrees. So what Pythagoras theorem says that when we square the longest part, that is the hypotenuse, should give us the sum of when we square AB and AC. So from this diagram drawn, let's put in, let's say this is B, and then this is C, and this is A. Pythagoras theorem says that when we square the hypotenuse, should be equal to when we add the square of B and then A. So in simple, for us to get C, we can say that let's square root both sides. By squaring both sides, this one square go to B squared plus A squared. We put all of them in a root. So we square root both sides. And then by squaring both sides, our root is square, we cancel this root. Let me see, let's go to root of A square plus B square. So you have our C to be equal to root of A square plus B square. Okay, so this is actually the value for C in terms of when we're using the Pythagoras theorem. With the same thing too, we can find B and C. We are asked to find B, we can also use the same formula. C squared is equal to A squared plus B squared. Okay, so if you want to make A the subject here or find A, we just have to make A the subject out of this relation. So we can say that let's C squared, B squared is positive when the close equation become minus B squared. Now go to A square here. So for us to find A, we square root both sides, square root this one, and then you square root this one too. So square root of A give us A, and then square root of this one, put them in the roots, so get your C square minus B square. The same way, if you want to find A, use the same formula. Say C square is now equal to B square plus A square. Don't worry about the a square plus b square or b square plus a square or a square plus b square, because addition is commutative. We can change them and still have the same result. So let's try and see if we can make b the subject here. To make b the subject, write c square and then a, of course the equal sign to where c squared, so get minus a square should give us b squared, because we want to make b the subject. So we square root both sides. By squaring both sides, I'll c square minus a square. We put them in the roots very nicely. We equal to b square. So put it in a bracket. Put them in the square root. So square root of b square will give us b. So we can say that finally our b will be equal to the square root of c square minus a square. So actually this is how the formula that you can use to actually find all the sizes of a rectangle, triangle. So let's already define what a hypotenuse is, and then the definition for hypotenuse is the longest side or the side opposite to the right angle. So let's take example and see how we can tackle questions using the Pythagorean theorem. Let's say this is a right angle triangle. A right angle triangle here. Then there's arrow, Q, and then P. Okay. And then having this side being 12 meters and this being 5. The question is saying that we should find PQ. So we are finding the longest side, that's the hypotenuse, finding PQ. So for the formula, we say that the hypotenuse square should equal the sum of the other sides squared. So we can put in a simple way. Let's replace here by, let's say, z to make it very simple. So we can say that z square should go to 12 square. 12 square plus 5 square. Because we've established the fact that the square of the hypotenuse should be equal to the sum of the squares of the other sides. So we see that z square now equal to 12 square. 12 times 12 gives us 144. 144 here plus 5 square gives us 25. So 144 plus 25 gives us 169. So we say z square equal to 169. But we don't need z square, we need z. That's the hypotenuse. So we square root both sides. So square root z square and also square root 169. So the could give it away with the roots. So we have z is now equal to. And then one thing we should know that 169 is a perfect square. And then the perfect square means that a number square should give us a 169. So a number square is 13. So 13 square is able to give us 169. So we say root of 169 is 13, like this. So this is how we solve questions using the Pythagoras theorem. So let's try another example and see how we can solve more questions. So this will be our example 2. Example 2 here. So this one too, the same thing. Let's take our question nicely from this way. It's a right angle triangle. Okay, my right angle triangle is having a problem here, so let me clean here. Then try to make it very nice. Okay, so just draw this one to this place, and then join. Let's take it right. They not want to scale, and then this is 3 centimeters, and this is 5 centimeters, and this is A. So triangle ABC, and then we are asked to find line AC. So if you find line AC, if you see something like this in mathematics, stand for the line or the magnitude of the line. So we want the magnitude of AC, and we know that from the previous tutorial, we know that if you want to find any side using the Pythagoras theorem, we say the longest side, that's the hypotenuse, square should be equal to the sum of the square of the other side. So let's see, you say that the magnitude of BC, the magnitude of BC square should be equal to the sum, so plus is equal to magnitude of AC square plus the magnitude of AB, and then square. So now in our question they provided the magnitude for the hypotenuse, or given the value of the hypotenuse, that is A. BC has been provided, so just substitute the values. So BC is now 5, put 5 there, so 5 square is equal to AC. AC has not been provided, so we are looking for AC, so we put the AC there, square plus BC plus AB. AB has been provided, which is 3, so put the 3 square, very nicely there. So we move on, and then 5 square will give us 25, so write 25 here is equal, what we are looking for is, we are looking for AC, so but AC is not provided, so you see that 25 is now equal to AC square plus 3 square will give us 9. Because we need AC, all that we need to do is that we send the 9 to where the 25 is. So now 25 minus 9 equal to AC square. Okay, so 25 minus 9 give us 16. Okay, so 16 now equal to the magnitude of AC square. All right, so now I have 16 equal to AC square, and then we are looking for just AC. We need AC and not AC square. So all that we need to do here is very simple, that we square root the AC, and I will do the same thing to the 16. And 16 is a perfect square. When I talk about perfect square, a number square, a number twice itself, we produce this result. So a number square to get 16 is 4. So 1 square 4 square, that's 4 times 4 give us 16. So okay, the root of 16 is equal to 4. And then these two we deal away with the root, and then you get the magnitude of AC here is equal to 4. So therefore we say that the magnitude of AC is not equal to 4 centimeters. Okay, so let's try the last example, so far as Pythagoras theorem is concerned. So there's a diagram, so we take note of the diagram. It's a diagram here. Diagram not drawn to scale. Something here. Alright, so see that diagram is just complete like this. And then this is making an angle of 90 degrees here. Okay. Making an angle of 90 degrees here. And then if Q here, P here, and then arrow, then N here. So this is how the diagram looks like. And we have 13 units here, 15 units here, and then we have 12 units in the middle like this. And the question is saying that calculate the length of QR. So we have to calculate for QR. So we are looking for QR. How can we calculate for QR? We can find QR simply by finding Qn, and then also finding, so we want to find QR. You know, QR is this line to this line. So to find QR, we have to find line Qn, and then we add it to the magnitude of nr, because we can solve for nr simple form and solve for Qn very simply. So let's try and see how we can solve for Qn and nr. So we can say that Qn square Qn square is equal to, let's just put in the values, is equal to 13 square minus 12 square. 13 square minus 12 square. All that we need to know that from the diagram, QP is the hypotenuse. QP is the hypotenuse. So the hypotenuse square should be equal to the sum of the other side square. So the hypotenuse square, that's QP square, is equal to QN square plus NP square. So now we want to make Qn the subject. Then it's going to be 13 square minus 12 square. Just give it a value. So here we just find here 13 square will give us 169. So write 169 minus 12 square will give us 144. Right. So now we want our Qn, not Qn square. So 169 minus 144 gives us 25. So now the whole of this will reduce to 25. So now we can bring our magnitude of Qn here. Now Qn is written here very perfectly. And then because we want Qn, no Qn square, we square root this, and then we square root this one too. So 2 we deal away with the root, and we're left with the magnitude of Qn. The magnitude of Qn here is equal to root 25, give us 5. Okay, so now we are done with Qn. We can also calculate for nr simply because we know the hypotenuse, which is 15, and we know the other length to be 12. So therefore, Qn can quickly be calculated. So we can say that the magnitude of nr square should be equal to 15 square minus 12 square. And then our magnitude of nr square should be equal to 15 square will produce 225. 225. All right, 225 to produce 225. Okay, just nice. 225 minus the square of 12 will give us 144. Like this. So we have our nr square should be equal to, when we subtract 144 from 225, we get 81. So we have our nr square to equal to 81. So we need nr. So we square root this one, come and square root this one too. So square root of the square, we take away the root, and then we leave it the magnitude of nr, and give us 81. Square root of 81 is equal to 9. So now, for us to now get the magnitude of QR, you see the magnitude of QR is equal to the magnitude of NR plus the magnitude of QN. Q and then N. Q and N. So now you have our magnitude of QR perfectly. Our NR, what do you get for NR in the question? NR was 9. So we write the 9 here plus our QN was 5. 5 here. So now our QR is equal to 9 plus 5, which is 14. Okay. So thank you for this tutorial. Thank you for your time, and I know it's going to be very helpful to you.